Here's how to do volume with cross-section questions in 60 seconds. Let's go. This is the base of our 3D shape with semicircle cross-sections. Here's the full image. As you can see, there's a semicircle that stretches from the x-axis to our red line from before at every single x value between bounds A and B. So there's an infinity of them and they form a 3D shape. We find its volume with this formula, but we need the area of our cross-section first. To get this, we need this green line, which I'll call S, which is the top line minus the bottom line. To find the bounds of our integral, just set f of x equal to g of x and use your brain. These are expressions for different cross-sections. There is also this k variable, which will appear in questions as the height is 7 times greater than the base, with 7 being your k value. These are pretty easy to figure out on the spot, but you can just memorize them and it'll save you lots of time. Special rule, if it's perpendicular to the y-axis, either turn your head 90 degrees or swap all the x's and y's. Example question, area between two lines f of x and g of x, base of a solid, and this solid cross sections perpendicular to the x-axis. Height is 7 times greater than the base, f of x is given, g of x is given, asking for volume. Okay, first we're going to find where the lines intersect. We're just going to set the two equations equal to each other and we get -2 and 2. So this will be the domain of our shape basically. We're going to pick a test point within that domain, which I'm going to use 0 because that's easy. We plug 0 into both equations and we find out that g of 0 is greater than f of 0, which means g of x is the top line. And then we just set up the integral. This is a expression from the formula page from before. For the triangle, I just plug in everything, including our k value, top line minus bottom line. We solve. I just brought what we had up to the top, evaluate the integral, plug in our bounds. If it's non-calculator, you can just add units and leave it like this. But if it's a calculator question, we got to calculate it, and I got these numbers pretty easy.